Welcome to our video on building the James Webb Telescope. Over the next 10 minutes, we will take you on a journey through the complex process of designing, building, and testing the most advanced telescope ever constructed. The James Webb Telescope is a collaboration between NASA, the European Space Agency, and the Canadian Space Agency. It is designed to be the successor to the Hubble Space Telescope and will be used to study the universe's first galaxies and the origins of life in the universe. The development of the James Webb Telescope has been a massive undertaking that has required years of research and development by some of the world's best scientists, engineers, and technicians. In this video, you will learn about the challenges that they have faced and overcome in building this magnificent machine. The James Webb Space Telescope is considered a technological marvel in the world of astronomy and space exploration. With its unrivaled capabilities in detecting and observing celestial objects, the telescope is set to revolutionize our understanding of the universe. Scientists expect that the massive telescope, roughly the size of a tennis court, will be able to capture images of the first galaxies formed in the early universe, enabling them to study the evolution of galaxies over time. In addition, the telescope will be able to analyze the atmospheres of nearby planets in new and unprecedented detail, providing groundbreaking insights into the workings of planets within and outside our solar system. The James Webb Space Telescope is poised to take the scientific world by storm and rewrite the textbooks on our understanding of the universe. The process of constructing the primary mirror of the telescope was delicate and intense. Each hexagonal segment, comparable in size to a car's sunroof, was crafted from beryllium. Beryllium was chosen for its unique properties of being lightweight, extremely strong, and stable. However, to ensure the optics of the telescope were of the highest grade, each segment needed to be aligned precisely to within a few nanometers. This level of precision required extensive planning and execution, as even the slightest misalignment of the segments could have resulted in a flawed image of the celestial bodies captured. With these factors in mind, the team assigned to construct the primary mirror worked relentlessly to ensure the mirror's shape remained perfect, making it capable of capturing detailed observations of the cosmos. To ensure that the James Webb Space Telescope can observe the universe with precision, it needs to be kept cool. The sun radiates infrared radiation, which can interfere with the telescope's sensitive instruments. Therefore, to protect against infrared radiation, layers of a special material as thin as a human hair will shield the telescope from the sun's heat. These layers will constitute a 5-layer sunshield. However, such a sunshield is large that it to be folded like an origami puzzle to fit inside the rocket during the launch. The JWST has a sunshield that is roughly as large as a tennis court and will open up in space to shield the telescope from sun. The series of tests that the telescope will undergo are crucial to ensure its success in space. It is necessary to simulate the harsh conditions of space to determine if the telescope is durable enough to withstand any possible damage. The tests will include exposing the telescope to extreme temperatures that mimic the varying temperatures of space, and exposing it to vacuum conditions to test its ability to operate without air. The effects of radiation on its instruments will also be tested to determine its capability to function properly. Any flaws or defects found during these tests will be corrected immediately to minimize the risk of failure during launch. The telescope's ability to withstand these rigorous conditions is essential to the success of its mission in space. The Ariane 5 rocket is a dependable means of space transportation, trusted by scientists and researchers all over the world. Its ability to carry a heavy load makes it a favorite among space agencies, and the James Webb Space Telescope is no exception. The telescope will be packaged carefully and secured in place at the top of the rocket before takeoff. The rocket will then blast off into the atmosphere with a thunderous roar, carrying the telescope to its final destination at L2. Traveling about 1 million miles from its home planet, the telescope will be protected from the brightness and heat of the sun by a sunshield the size of a tennis court. Once in position, the telescope will begin to capture never-before-seen images of outer space, expanding our understanding of the universe beyond what we ever thought possible. As we wrap up this video, we cannot emphasize enough the sheer magnitude of the technology and expertise that went into building the James Webb Space Telescope. From its design to construction and testing, every inch of the telescope has gone through thorough scrutiny and rigorous testing. With its launch scheduled for late 2021, We eagerly await the breakthrough discoveries that the James Webb Space Telescope will foster. By peering into the depths of space, this instrument will help us unravel some of the universe's greatest mysteries and provide us with essential information about our place in the cosmos. The James Webb Space Telescope is poised to change the way we view the universe and unlock new frontiers of exploration.